All right, guys, so if I ask you what's the domain of this, in fact, let me even make it more official. To make it a little function. Yeah. What's the domain of that function? What's domain mean? What about x? All the x values that you are able to use. I love it. That's it. The domain is a grab bag of all the values you're allowed to plug in for x. So a quicker way to answer the domain question is to think, sometimes it's to think, well, what can I not use? Because there's a lot of things you can use. Maybe there's only one thing you can't use. So what can I not use? Yeah. So one way to write the domain here would be x can't be negative 9. Is everybody cool with that? Why can't it be negative 9? Because the bottom 0 then is under 5. All right, and we don't want to let that freakiness happen. Now, a slightly better way to write this domain is from negative infinity up to what? Where do I want to stop? I can use every number until I hit negative 9. Oh shit, so I better skip negative 9. So I can use all these numbers, or all those numbers. So I think we've seen this before, and I just called this thing in the middle, I call that skip. I want to skip negative 9. From negative infinity to infinity, oh shit, but skip negative 9 because weird things happen for negative 9. All right. Everything I just said is old news. This is all old news. All of this. So we're about to get into slightly new news. The thing with, if you ever see a question about domain, you just say to yourself, what would make a problem? Here, what would make a problem? Any x values that make the bottom 0. That tells you how to solve it. So what would make a problem for this guy? Question.
Thank you.
You're allergic to that. So now think generally. Just think generally first. That is a root. That's a square root. What kind of number can I not allow inside that square root? So the inside can't be negative. So the inside has to be what kind of number? The inside has to be positive or can't be negative. We just said it. I love you guys. Yes, exactly. I love it. I want more. All right. I'm with you. Please, come on. Please stay with me. Now watch. Here, in English, bottom can't be 0. Okay. At least when I speak it, it's English. When I write it. Here, in English, inside at least 0. So domain is awesome. You start with just saying in English what has to happen. Well, the inside has to be at least 0. Okay, now translate that to math. What's the inside? No. What's inside? X minus 1. The inside has to be at least. I know, but how do you write at least? In mathish, greater than or equal to 0. So in English, what has to happen, and then you write that in Mathfish, and then you solve that math sentence. How do I solve this? Add 1. So x has to be at least 1. How do I write that in interval notation? Bracket. 1 up to infinity. You can always do that with the square root. You just take the inside and you force it to be at least 0, greater than or equal to 0. And if you solve for x, that will tell you the values of x that make sure that happens. Why do I want this? Because otherwise I get those freaking imaginary numbers that Jeff forced us to watch on the video. Yes, sir. So you guys do number 2. We got a lot more people today, I feel. I don't know, you guys, anybody sick currently? Like, I'm not going to identify myself as sick. What are you talking about? I don't know what happened yesterday exactly. Well, I can't force people to be here. Okay. So how do I set this up?
3x minus 1.
And the inside has to be greater than or equal to 0. And now if I solve for x, I will find the values that make sure that happens. Add 1. Good Lord, Jeff. No, Jeff. Okay. And then divide by 3. I like it. So now in interval notation, this would be bracket 1/3 infinity. Now before you start saying, well then it's always number comma infinity. Number 3. Now real quick, I want you to realize something. Let me go back to something we're a little more familiar with. If I had a function that was 7 plus 1 over x minus 1, what could x not be? 1. X can't be 1. Did the 7 do anything to that consideration? No, it didn't do anything, because that's 7. It doesn't have a problem. So what part of this has a problem? That dude. Okay, go. Figure out that domain. That 3 plus doesn't do shit. It doesn't have a problem. Focus on the part that has a problem. That's what's going to restrict the x's I'm allowed to use. I know. There you go. Yeah, that's true. Okay, so this shouldn't be too bad if you remember something about inequalities. So you get the inside has to be greater or equal to 0. Now me, I would add x and then turn around. But you could subtract 4, and then what do you have to do? Divide by -1. Exactly. the sign has to flip. So what would that look like in interval notation? Yeah, negative infinity up to 4. Right.
So just completely forget about the 3.
Say again?
Completely forget about
Exactly. The same way we totally didn't give a shit about the 7. What part of this has a problem with some values of x? Just this part. In fact, just this part. No. This 3 is there because it could possibly be there. You don't have to. Yeah. So, no, it's not a trick question. There are functions that look like this. So you have to understand that the only part you got to worry about is the part that would have a problem. The 3 is fine. It's only this that wouldn't let me. If I try to plug x equal to 5 in here, what happens? I get something that's not real. The 3 doesn't save me. It doesn't do anything for me. Right? If that wasn't there, the domain would be exactly the same because it's only in here that there's a restriction. The 3 doesn't matter. The 3 is just 3. It's fine. Okay. Now I get some new stuff. In fact, if you're paying attention, this is actually the last new thing we're doing this semester at all.
You'd be skipping.
Thanks, John. Yeah, John. That makes up for the amount of shit we've done. Now, to be honest, you know how to do this. You've been doing this your whole life. Not your whole life. Help me out. What is 3 times 2? Why were you able to multiply them together? Because they have the same root. Namely, they don't have a root. You can only multiply 2 numbers together if they have the same root on them. So can you multiply these together? Because they're both under a square root. So the square root of 5 times the square root of 2 is square root of 10. Because 5 times 2 is 10. So what's the cube root of 5 times the cube root of 2? Cube root of 10.
Sorry. Oh. My bad.
That's all right. So what's the square root of 5 times the cube root of 2? Can't do it. I love it. You guys, they have to have the same root. So that it sort of makes sense. On one hand, it's kind of like, if they didn't have the same root, what the hell would be in the answer? So like, you can't put x plus y together. You can say, well, it's xy. I don't have any xy's. All right, do number 2. What you can do, it's just a big old square root, and you just work with it. What do you get when you multiply these together? Sure, you can do all that. Or you can realize that this is just a difference in squares kind of thing. The middle terms are canceled. Now, what makes me really, really sad, how do I know from what I've done that this cannot be simplified? Because this is not the product of something times itself. These are 2 different things, are they not?
Yeah.
You can't do one more step. Does everybody see that? What step do you think somebody would want to take here? X minus 2 something. They want to, half of x squared is x and half of 4 is 2. There you go. No, that doesn't make any sense because I really want this to make sense. What's the square root of 49? Because 7 times 7 is 49. So if this is x minus 2, that must mean that x minus 2 times x minus 2. No, it ain't. X minus 2 times x minus 2 is not this. There is nothing times itself that gives you this. There's two different things we multiply to get here. So my math 285 students, yeah. Talking about you, if you're looking at this video. I told some of them to go back and take a look at my math 9 freaking videos. I'm sorry. It just makes a teacher a little bit sad when you have somebody in math 285 that's having trouble with this. Now you guys, this is brand new. If you have a little bit of trouble with this, I'm not going to snap your head off. Please, you're at this level. That's fine. But does that make sense? You can't. In fact, roots are the same level in order operations as exponents. Next semester, you'll learn that roots are exponents. Like a square root. What exponent do you think a square root would be? What's the square root do to something? What's the square root do to something? Cuts it in. So a square root is a 1/2 power. So I guess officially you could say you just learned it. So next semester you'll work with fractional powers. Those are related to roots. I love it. This semester you don't have to worry about it yet. Alright. So you can't do square root across subtraction. They don't play well together. Okay. So let me ask you this. If I can multiply things together like this, I should be able to factor them back apart the same kind of way. So for example, if I had, what you got, Jeff? If I had the square root of 15, can you break that up for me?
Square root of 5.
Square root of 5?
Square root of 3.
Square root of 3. I love it. You guys with me? Now, does that help me at all? No, it's just sort of the same level as factor 15, 5 and 3. What the hell does that do for me? Well, we should know how to do it. But sometimes doing this will help us. So what do I mean by that? Square root of 27. Do you know what the square root of 27 is? Well, no. I just mean, what's the number answer? I don't freaking know. What's the square root of 25? So the square root of 27 is a little more than 5. Right? So you can say, I think it's about 5.1. You know, and then check it on together. Now you're going down the right path. Take 27 and break it up. But I want to break it up in a way that there's a part I can do and a part that I can't do. So what is 27? It's 9 times 3. So square root of 27 is the square root of 9 times the square root of 3. And square root of 9 you can do. Yeah, 3. And square root of 3, I don't freaking know. Now watch, I want to show you an analogy with something from earlier in your math life. Just go with me for a minute. Because a lot of times you don't even see this, what I'm about to show you. If I had 17 over 4, right? And let's say you're back in 88. What would probably your teacher say to do with 17 over 4? Make it into a mixed number. So 4 to 17, you set up your division. No, screw that shit. Why is 17 suck with 4 on the bottom? What would you rather have up there that's 16? Something that's right below 17. So couldn't I say this is 16 plus 1 over 4? Same stupid thing, right? Do you see how it's the same idea here? I'm breaking it up into a part I can work with and a part that's just going to sit there. So now I can say, okay, this is 16 over 4 plus 1 over 4. What's 16 divided by 4? 4 and 1/4. Bam. Are you guys cool? So you don't have to involve division really, you know, like long division, and big old R or whatever. Okay. So that's really the same idea we're applying here. So what if I had, what do they give me here? Screw that. What if they had square root of 50? How could I break that? Now I can break up square root of 50 as square root of 5 times square root of 10. Why is that kind of a silly way? Because 5 and 10, I still can't do either one of those either. Wow, good job. So I'd rather break it up, of course, as 25 times 2. Because the square root of 25, I can do something with. So you break it up into a part you can do and a part you can't do. And then guess what you do? You do the part you can, and you don't do the part you can't. It's amazing. So the square root of 50 is the square root of 25. That's the square root of 2. Square root of 25 is? 5. Square root of 2 is? 2. I do sort of know, but Alright. There, you guys try. Let me pick you out one that's not too tricky. Yeah, I like it. Number 3. Number 2 is sort of, well, try number 3 first. That's exactly like what we're doing right now. Number 2 is sort of a holdover from the last thing we did. So how are you guys breaking up square root of 44?
4 and 11.
Yeah, square root of 4 times square root of 11. Square root of 4 is 2. Square root of 11 is, I don't know. Yes?
Would it have mattered if you did 11 square root of 2?
Yes, completely. That is totally different. I need you to understand. Let me try to say it this way. How many things do you need inside a square root before it can be done? That's a weird question. So why can't I do the square root of 3? Because it's just 1, 3. There's no 2 things that go in 3. So why can I do the square root of 9? Because now 9 is 2 3s. So what do I have 2 of in 44? 4 times 11, I have 2 2s. That should be the only number that I can actually do something with. There's only one 11. There's no way it can come out of the square root. Yes?
So the one that you break down the furthest is on the outside.
No. Now watch. Please understand. There is zero ambiguity here. Are you cool with the first step? Square root of 4 times square root of 11. The square root of 4 is 2. I don't have to guess. I don't have to wonder. Square root of 4 is 2. And what's the square root of 11? Square root of 11. I don't have a clue what square root of 11 is, right? Do you guys understand? You do the one you can do, and you leave the one you can't. So there's no like, which number goes out front? No, you're thinking about it wrong. You do the square root, the root that you can do, and the other one just stays there. I like it. So there's no ambiguity about what number goes out or whatever. I like it. Real quick, what about number 2? Let's see who remembers what they say in the instructions here. Oh, okay, it did say it. We are assuming that the variable is positive here. Because officially, what should this be? But they didn't say that. No. It should be 2. No. Yeah, no. Shit, let's review. What's the square root of x squared? It's not x.
Oh, the absolute.
Yeah, it's the absolute value of x.
Oh, absolute value.
To cover our ass for in case the variable is negative. Now, in general, that is what it is. You with me? In general, that is the square root of something. If it comes out where it's possible for it to be negative, I've got to put absolute values on it. Because what's the answer to a square root always got to be? Positive or 0. If it's 0. The answer to a square root cannot be negative. They have to put a negative sign on it to say, okay, make it negative. Now, why is this one okay to do like that? Because they said, henceforth, ooh, I like that. Henceforth, we will make the assumption that a radicand does not represent a negative. Oh my God, it's crap. They're saying that the variables won't be negative. And one reason we do that is just because there's too much other stuff going on, really, for us to remember to put absolute values around everything. Okay. All right, so let me do a couple more just straight numbers, and then I've got to see what happens with variables with this idea. What's the square root of 45? How do I do that? Yeah, square root of 9, square root of 5.
3 square root of 5.
No.
Square root of 9 is?
3.
3.
So then 5 is 5.
You see it? Yeah, the 5 isn't outside. Yeah, which is a totally different number. Okay. I want to make that absolutely clear.
How would you do
Completely
number?
wrong.
How would you do number 5?
We're getting there.
Oh, yeah.
All right. All right, guys. All right. Let me explain this. That's what you do, Jack. That's your job. Thanks. And then the shortcut to this is so freaking awesome. The way you've said this almost your entire life is the way you write. So here's what I mean. So remind me, let's do one that's nice. What's the cube root of m cubed? Two things. Cube root can be negative. I don't need absolute values. Secondly, we're assuming that they're not negative anyway. So what's the cube root of m cubed?
Absolute.
M. Now again, help me out. What's the cube root of negative 8? It's not 2 because 2 times 2 times 2 is not negative 8. What's the cube root of negative 8? Negative 2. So why can a cube root come out negative and a square root can't? Because if I have a negative number times itself 3 times, can the answer be negative? Yes. That's why even roots can't handle negatives, but odd roots can. Because you always have an odd man out. That one. All right. Okay. Now watch. It's too nice to believe. So what the shit would cube root of m to the 4th be? How many extra m's are inside? 1 extra m. So now, stay with me. I'm going to show you the reasoning, and then I'm going to enforce the shortcut, because the shortcut is so freaking beautiful. Can't I write this? Can't I do this the same way we just did square root of 45? Wasn't there like an extra factor of 5 on top of the 9 that was in my way? And then I just move it the shit out of the way. So can't I do this? Cube root of m cubed times the cube root of m. What's cube root of m cubed times the cube root of m? What is that? The cube root of m to the... Okay then. What's the problem? I did the exact... What did I do with this? I broke it up into 2 things that multiply to be it, so I could do part of it and leave the other part there. I kind of moved that extra piece over. So here, what was the extra piece? The stupid extra m. So what's the cube root of m cubed? M. Cube root of m? I don't freaking know. No. So it's the same idea as the numbers. Now watch what's so beautiful about having something written with exponents. Let me remind you guys. Why would this be easier? Cube root of m to the 6th. Yeah, because 3 goes into 6. So what's the cube root of m to the 6th? Square. Break it into 3 parts, right? So now watch, here's the shortcut. 3 goes into 4, how many times? Once, with 1 left. Please let that be beautiful. We do another one. What if I had the 4th root of a to the 10th power? 4 goes into 10 twice, with how many left over? 2. You see what I mean? But the way you've said it ever since you first learned it is the way you write it. It goes into it 2 times, so 2 A's. With 2 left inside the stupid radical is what you mean. I don't need you guys to be jumping up and down for joy. Please let that shortcut be nice. Let's do another one. Just forgetting about their crazy problems. What if I add the 7th root of a to the 25th? 7 goes into 25. 3 times with 4 left. Now, why does that shortcut work? Because what I'm really doing is, what number do you wish was here that's right below 25, 21? So can't I break this up as 7th root of A21 times 7th root of A4? Does that make A25 together? So I can break it up. This I can do. This I can't do. But instead of doing all that extra work, let me just go 7 into 25 3 times with 4 left over. Bam. Bam. Okay. All right, let's do another. What about if I had cube root of a to the 8th, b to the 17th, c to the 48th? What? What's your problem? So then 3 goes into 8 twice. See how I leave myself a little room? With how many left? 3 goes into 8 twice with 2 left. 3 goes into 17. 5 times with 2 left. 3 goes into 48. Oh, okay. You were very confident. Yes. It's a big 3, Jeff. 3 goes into 48. 16. With nothing left. Yeah, 3 goes into 48 evenly. So that's why there would be nothing left. Make sure that that's a cube root there. Alright. Ooh, we got some time left. Do number 7. Guys, do number 7. What's that? There are a few different ways to do these problems, yes. Whichever way makes the most sense, you do it that way. Would you guys like to get the practice final now, or?
Yeah.
Okay, I'll give it to you. All right. I heard a couple of those, but you can just take it. That's fine. I have these. I might as well get them. Just to remind you guys, in case you weren't here when I said this practice test, the practice test for next week, I'm going to email it out because I decided to do this instead today, just on a whim. I don't know. That way. So the numbers act one way, and the variables act another, as often happens. So 20 would be, yeah. So I get 2 with a 5 left in. Now you start doing the variables that shortcut way. What's the understood number in there? What's the number? There's a 2 here. 2 goes into 3 with 1 left over. 2 goes into 6. 3 times with none left over.
Why did you, how does the whole thing?
What's that?
How did you know that you had that 2 outside of the?
What is the square root of 4?
2.
2. So I'm not putting a 2 outside. Square root of 4 is 2.
No, I mean like above, like right next to the.
Oh, it's a square root, so I just put it there so I could point at it.
Why did I think we could do that? I know, I was sorry, okay, so.
What'd you think it was?
I didn't know why you could put it there, and then.
Oh, it's there. It's there. It's sort of like you can put 7 over 1.
Yeah.
There's a 1 there. We just normally don't write it. There's a 2 there. We just normally don't write it. Yeah.
Is it gonna be like this, many questions?
I have no idea. Is that great? Thank you, Jack. I cleared that up. We'll talk more about final next week. All right. So I'll see some of you guys in a few.